Yule. And today, we try to go through a series of projects which I think is really interesting because it shows kind of the process of not just using digital tools for design, but also like adopting digital fabrication and like back and forth between like design and fabrication. And Yule is very specific in this part because you're not just only designing with the digital design, but at least since past 5 years that I know him, he also like developing a technology. So with this brief, I'm going to presentation swiftly.
It's my turn, right?
Yeah.
Hey, hello everybody. Okay, let's begin the presentation. I have to say thanks Ali to make this happen, and it's a great pleasure to share my experience of my digital design and the fabrication experience over the last 5 years, and I will barely show some videos. Each video has one project contents. And the first one, I would like to say, show you a briefing of my recent projects.
Sorry, are you showing a video somewhere? Because we only see the presentation. We only see a screen of a presentation.
Oh, okay. So
you need to share the screen.
Okay, let's.
Not a problem. It's just if you can show it. Perfect, perfect. If you are showing a video, okay, that's perfect.
Okay, this first video is a general introduction of the research of what's Yule doing in the past 5 years, which I had the pleasure to collaborate in a couple of them.
Whoa.
Meran, probably works better without the audio. We can see the images and the video, it's perfect. So let it go. I just turned off the audio at the moment. It was cracking quite a bit. Incredible project. Congratulations.
Back to okay, guys. Those video a brief introduction of my team's recent works. Since I just finished the presentation to my students, those the first few pictures we can skip it because it's well known and everybody has known the story. Yes, yes. So I will start from my first robot experiment, like 3 years ago. This motion capture and translation algorithm in Rhino, and we put the code into the robot system with a LED on the end effector and capture the track for 5 minutes. This is the first experiment, and then we switch to a bigger discussion about Cocoon. The Cocoon has a lot of inspirations for us because it's beautiful and it's light structure, and it has the materiality and the composition has a lot of point we have to learn through the new fabrication technology. The first one is robotic fabrication with multi-threaded extrusion, which I made with my team in 2014. So we investigate the spider silk and get a certain micro level. We figure out the spider, the physical feature of a spider is very strong because it probably has a spindle knot system, and we simulate this knot system by handmade model. It performed pretty well with small threading involved in, and the load and the whole structure stands up pretty good. So we developed a mechanical design to simulate the spindle knots with an open and closed movements. We can have a serial of the blob along the motion path of the robot.
Sorry, Beijing. Are you? 1 second. Are you changing slides or are you always at the third one? Because we are stuck at the third slide with the screen.
Oh, we are changing the slides.
We are changing the slides, Abdul. Can you see our slide?
Because I see the slide number 3. I don't know if the other nodes see the same. Probably it's just a matter of okay. Now yes, we see it's updated. Sorry, go on.
Oh, it's it's delayed. It's because of the connection is not very ideal. Okay, we go back to the mechanical design. Did you see the explosive diagram? Maybe they not. Right, it's like a few minutes delay.
We go back to these slides. Did you guys see this one?
I mean, we are understanding, and it makes sense, and it's also interesting to listen to your words. We are right now. We see the slide number 23. I guess it's related, no? Probably.
23. Where did you get a number?
23. Slide number 23.
I have no idea what slide.
Okay.
Maybe just use the PowerPoint. Yeah?
It's on the PowerPoint. I see the PowerPoint screen.
Yeah, okay, let's go on.
Okay, that's a mechanical design incorporated with Arduino system for synchronizing 4 extruder nozzles together with a robot, and slow down there. Slow down.
The slides.
Okay, you can. And this the setup the electronic hardwares. And this snapshot of the whole system and the detail of the end effector of the robot. And this is the first trial of spatial extrusion. And this picture has a series of phenomenon that the robot create a parabolic curve from 0 to its end. The parabolic curve actually is self-supported. You see there's only one standpoint, and the whole structure stay kind of still only because it's kind of a spatial organization. And there's a video. I hope everybody is able to. It's maybe decoded. No.
This one.
Okay. Share window again. Sorry, I will switch the video play sharing screen.
Ali, if you can send me also the slides, I can visualize the slide on my computer. You know, in real time.
No, it's too big, Aldo.
Ah, okay, well, okay. Let's go on. But I doubt that we can see. I see you, now I see you, but it's just problematic to see the updates of the slide.
Like we need to connect to the VPN and to connect to the Google services in China, and it's right now. I mean, since yesterday we actually had lots of problems. So
I will try to modify post-produce the video and match the slide afterwards. So go on. In any case, I doubt just that we can see the videos in real time.
Okay.
Remember to share the screen.
We right now let's. Did you see our screen?
I see you.
Okay, you see me.
Okay.
Okay, go back to the slides.
Did you guys able to watch the video?
Yes, we saw it. Perfect. Thank you.
Okay.
Okay, the next project, we will cooperate with Ali in 2015, which is the last year Dada as Digital Fabrication International Conference happened in Tongji, Shanghai. This time we want to build something architecture scale with 3D printing technology and a very generic building material, concrete. So we call it a concrete strip because it's a fiber concrete is a new material. It has a certain kind of a toughness to reach a large building scale. So we think probably the 3D printing filaments could cooperate with concrete cement to generate the same result. So firstly, we go to a vault structure. We have been working on this for years with a certain kind of experience. We create a form in Rhino Vault. It's a plugin created by Dr. Philip Blocks. And we printed out the small model to examine the form and the space. And then we tested the form into a few planar pieces, which could be reassembled for the original form, and we put them on the 3D printer with number. We get the form back by put those 3D small panel back together.
Sorry to interrupt again. Please don't put the images, the slideshow at full page, because we can see the presentation with the single slides, and if everything is perfect, I think it's the problem is when you put everything full screen. You know, okay, exactly. If you stay like this, we can see everything. So keep it like, and for us it's perfect. That's why we couldn't see it before. Keep it like that, please.
All right, it's cool. All right, it's better.
Thank you.
Okay, we put certain load on top of this light and thin structure with only like 3 millimeter thick. It's, to our surprise, it's very tough. It's overload like 20 kilo on top of it, and with only very small, subtle deformation. So we think in this way we probably could build a larger one. The second case is how to simulate the fiber through 3D printing. We use our custom-made code to make this. That means we have to develop an application, a program to generate the 3D printing G code directly through it instead of using the open resource or commercial programs. And it turns out pretty successful. Next. Oh, that's the Grasshopper program we use for the G code generation, and we also have a bunch of house-made huge 3D printer. Okay, and the next one is the first test. Okay, we just use these, right? Yeah. So on the left side, you see Ali with a lot of box, and we print everything in Beijing, and we deliver that prints over to Shanghai and put them back together on site. And this is a test block of concrete cement together with the 3D print filaments of 3D printed silk. We also use the robot to inject the cement along the path of each block to accurately control the molding work. And this is the installation on site. We barely use scaffolding, only with a few recycled boxes for temporary support. That is because each panel has geometrical detail, a geometrical feature with a neighborhood. So in this way, it's the precision of 3D printing technology gives us an opportunity to put all blocks together precisely. Okay, this is a detail of the cement pouring into the 3D printing panel. This is the assemblage. The scale ends up pretty big. It's like a 6 meter by 5 meter footage and 3 meter tall, and people can actually go underneath, and it's creating a small pavilion. And just some detail at night. Okay, there's another video which is please for a second. Actually, a lot of people over there. Get more and more people. Yeah.
We can move now. We can move and see that.
So Ali actually did a lot of work in calculation of this model. Can you hear?
Beijing, we only see one image, right? Stuck. Okay, okay, now yes. I guess. Okay, now it's good. Okay.
Okay, we go back to the slides.
Yes.
Okay, I have to say, great job in that project. He did super grasshopper work for geometric tessellation. And it was pretty busy last summer. We had a few workshops, and this workshop is automated robot assemblage, which we call the robotic bird nest. We're thinking of 3D printing or other kind of a fabrication method. I work with the building components, but you still need manpower to put them back together and to build it up. So if robot can take place, and it will save a lot of resource and more efficiency. So we put the bird nesting and the robot cooperation together, and we think they have to share the very a certain amount of similarity. So we decide to use robots to make a bird nest. And there's like
Beijing, are you sharing the screen? Sorry, sorry to interrupt all the time. Okay, because I just see the black screen. Sorry if I have to interrupt all the time, but yeah, it's not so easy.
Can you see in your screen?
Now I see it. So good. Probably it's better just to skip the video, and since this is working, we will see the videos in another moment. Let's stay here. Let's keep it here.
Okay.
Okay, cool. So go on.
Okay. So this project we try to use the automated building system operated by robot only. There's like more than 400 wood sticks, and pick it up and cut it by robot and place it on the right locations. Human being just use a glue gun to stick them together. So that's the diagram of how the whole system was set up. And also the simulation with birds by comparison. So the robot is to pick it up, a hook stick to pick it up by robot and cut by certain length. So all numbers is carefully designed in a Rhino, and there are like thousands of parameters, thousands of numbers for database. So I will just quick pass the diagram, and there's another video showing the whole process. This is the final result. It's mostly the wood stacking with each number in different locations and angles. Okay, we will go to another video. Just wait a second. Yep. Okay, the video just started.
Yeah, for the moment we see it.
Ah, great. We use this a lot, especially in the last sprint fast. Every single moment has to test the red and boy, all of it. All right. Go back to slides. Wait a second, please.
Successful.
Oops. Okay, just quickly pass those. All right, man. There should be a new slide on the screen, which is our biggest project in the last year. It's Guinness World Record stuff.
It's the biggest 3D printed structure. It had the world record for this one.
So we had a lot of experience from the Shanghai Tongji's workshop. We decided to make a bigger one in Beijing Design Week. The concept is from the volcano eruption, and I think that there's a beautiful space under the volcano eruption. So that's the final result after like 2 months hard work. And this is the facade, which is like very interesting. Yes. Oh, this is a public location in a super mall in Beijing, which is the highest level shopping place. This is the top view of the project, and you will see the silky scheme and the wall scheme in this project as well. But the dimension is much bigger. And this some diagram how we the isocurve the shape, and also the structural analysis is actually we go between engineering and architectural a lot for finding the most ideal. I mean based on the schedule, the most ideal form. And also the planner tessellation that tightly associated with our printer's printable area. So we have to put everything in consideration, either the design side or the fabrication side. Right. There are over 1,000 blocks, flat blocks in different thickness. They put together only by little wood chips. That's the consideration because this should be finished. The whole installation should be finished only within 2 weeks. That's one module. That's one. There are totally 3 modules. This is one module with the steel platform because it's a public space. We have to work in somewhere, not it's somewhere in the building, in the shopping mall, and we put wheels underneath the platform. It's mobile system, so we can put them together the night right before the opening of Design Week. This the construction process is mostly handwork because each panel has to very subtle relationship with the surrounding. So we have to use a adaptable system which is very simple, just by zip tag to bond them together, and they will fit in the right location by gravity. So snapshot in the process, and it's when the sun comes out, the shadow looks very nice. It's an interior space. You will look through the silky screen, and you find the space is a little bit different from a huge opening. And this our students, they doing the sewing work, and it actually use zip tie to bond them together. And this is the last piece. It's the top piece of one single module. After this fit in, we can just you will see more detail in the video. And yeah, this actually a lot of work. We work day and night for consecutive almost 2 weeks. And you will find the scale from the guy, on the ladder. And it's last night. We put 3 modules together. It's a very critical moment. Before that moment, nobody knows we're gonna succeed. As our construction team, some detail of the silky screen. Yes, this is a finished, different with different angles. During the Beijing Design Week, this space is totally open to public, so there are a lot of visitors. Only because they're so curious about how 3D print can be used for larger structure. Okay, there's another video. Just a second, we switch to. Oh, it works. This one works.
Our plan was not to pursue the Guinness World Record of the largest 3D printed structure, but a unique space in large scale. Because we believe 3D printing is such an amazing tool that we should do something relatively big as architects. The Vulcan Pavilion exclusively represents our long-term research over the past 5 years. We will keep following this trend and preparing for the next challenge.
Okay, this dismantling video, you will see how the structure worked, so well until it collapsed. Right? So we used 2 weeks to set them up and only 2 minutes to tore it down. Okay, next. Okay, we also have some commercial project by 3D printing recently. This one we just built. We use group of 3D printers for the bigger building parts, decoration parts, and this one is the biggest one we have ever built. You see, it's like a 1.5 meter in span. We also have a factory filled with 3D printer, and that's one is under construction. It's on it's on top of building corner at 12 meter in height. So how it looks on street, and some details at night. This is the joint we developed specifically for this project, because we use the PLA as very generic building 3D printing material, but we have to think how it was applied outside. And we use a lot of connections to reinforce the whole structure, the whole system on the structure as a somehow like curtain wall system. And this is another project which is under construction. This is just a rendering. We just printed it out, and we're waiting for the on-site work. And this is the building blocks. And we also do some coating. So we keep developing a lot of ways to enrich our experience. Oh, this is the last project we just got accepted by. This paper just got accepted by Acadia 2016. We call it highly informed robotic 3D printed polygon mesh. it's pretty long, sorry. So we develop a novel methodology. Maybe with a lot of people has been working on it, but for the maneuver of a robot, I think we have some special points, maybe some special contribution, because we want to build the polygon mesh naturally on its way, its geometric way, geometric organization, based on the strong dexterity of industrial robot. So this is one way we want to extrude it spatially along this polygon mesh edges orientation. Slow the slides. So we use the algorithm to give a complicated solution, because it's 3D printing. The contouring technology is used just layer by layer contouring up, bottom up. So if you put a nozzle on top of on the top layers, it will not give any confliction with the existing printing. But if you want to use the spatial extrusion, you have to consider a lot of effects, especially the robot nozzle with the existing printing, also the singularity and the self-lock of the drawbacks of the industrial robot. So we use the algorithm to simulate and optimize the whole process. So there's a lot of discussion. We wrote it in our paper. However, we will just roughly give the big idea how we manipulate the robot, especially the end effector with the polygon mesh. So we have working on a lot of angles which can we can solve the collision problem. We call it collision-free strategy. There's also like a decomposition of a polygon mesh model you will see on the right side of this slide. There's many ways to use the algorithm we have never tried before, but it ends up pretty good. We'll see the comparison between the the computer model and the real fabrication. And also the whole process will present with this video. Maybe it works.
Are widely used in art design, sculpture, and surface modeling. It is extraordinarily unnatural to fabricate frame shapes using FDM 3D printers because they are fabricated layer by layer, resulting in a slow fabrication process and low quality products. In recent years, various fabrication systems have demonstrated that the use of a robotic arm equipped with a custom extrusion tool can more efficiently fabricate frame shapes. In this work, we propose a fabrication sequence design algorithm to search fabrication sequences for general frame shape fabrication. The general fabrication sequence is collision-free and guarantees that the printed structures have small deformations during the whole fabrication process. In our experimental setup, we allow the extrusion head to have different orientations for fabricating different frame struts. During the whole fabrication process, the printed parts should be in a static equilibrium, and the extruder should avoid colliding with the previously printed parts when it moves. The fabrication sequence searching problem is quite challenging, as it is essentially a dynamically constrained searching problem. The collision detection between the printed parts and the fabrication candidate struts is sequence dependent, as is the printed node deformation. To solve this challenging problem, we develop a divide and conquer strategy that first decomposes the input frame shape into several layers via a constrained L1 optimization method. Then, we find a feasible fabrication sequence for the individual layers via a local optimization method, together with a backtracking strategy. To verify the validity of our algorithm, we build up an experimental robot system.
I hope it did not capture.
Finally, we compare our method with the FDM technology by simultaneously fabricating a bunny head frame shape of the same size. It can be observed that the fabrication time and quality of our method exceed that of the FDM technology. Thank you for your attention.
Okay, I have to mention that this project is a collaboration between my team and the mathematics group of Chinese Science and Technology of China. So in this last project, I think it is it's basically cover our studio 3 years, almost 3 years work. We have some physical reality came out, and we're still developing some schemes. Want to apply that on the building industry. We always want to target one with huge scale, especially for the future design development. But I think we also have a strategy to share our experience and knowledge with other teams, other professionals. I think we will have more discussion. We have more interesting to work with. Okay, that's the last page. I will thank Ali make this happen. I will thank everybody stay with us in this Yeah, we haven't had dinner yet.
Okay, so we try to shrink it as much as possible. I hope you grasp the idea because it for us was having a good connection to for broadcasting was difficult. I hope you kind of progressive methodology because many of them are just like a prototype for finding a better version of algorithm or methods going back and forth from design to fabrication. Although, can you hear?
Yes, a little bit cracking, but just the last few words. But I guess all the rest of the presentation was quite clear. Those projects are absolutely interesting, and I guess it's perfect also for the introduction of our next week here, that is going to be focused on fabrication. I'm also looking forward to send the result of our students there in Beijing. So they still don't know, but they're gonna be exhibited there in September, October. So we're gonna have all the results from here there in Beijing with you. I guess this is a very, very nice collaboration that we are building with you. And there are a lot of points in common. I saw the material project, and I guess all the research and the effort that you are doing in order to apply this research to the construction site and to the field scale architecture is the most impressive one. So really great job, and I'm so happy that you could show it to us. We made it. Now we hacked the system at the end.
Thank you.
Thank you.
Bye, guys.
Bye.
Bye.
Bye. Thank you.
Tehran Khudafez.
Gracias.
De nada. You are welcome. Come to visit soon. Bye.
Yeah. Grab a drink.
Bye.